So let us look at the work done of a moving charge and electric potential of a moving charge. So work done, work. So if we are talking about what work done in a moving what charge, let me complete it. Work done. So you can now say what work is done to bring a charge from to bring a charge Q from one point to another, from one point to what? To another. The work is done to bring a charge from one point to another, and the amount of work, comma, the amount of work done to bring two charge near each other. The amount of work done to bring two what? Charge Q1 and Q2 near each other can be obtained as follow. Can be obtained as what? As follow. And I said what? This work done to make a charge. This work is done to bring a charge. You say what? This work is done to bring charge from infinity to the reference point. Good. Let me use diagram to explain it. If you have what? A straight line that contains two charge Q1, Q2. The distance apart between the two charge, we call it R in centimeter. The distance was apart. And the work done here, for what? Work is from force times what? Distance. What is distance here is R. What is force is F. You can now say what? Recall from Coulomb's law. We say that what? Force F is KQ1, Q2 over what? R square. Let me substitute for what? For force here. You will now have what? The work done should be what we have. We have K, Q1, Q2, the what? R what? Square. Multiply by distance. What is distance? Distance what? R. So this distance will cancel one R here. And the result of that, we are going to have what? The work what? Work be equal to what? K Q1 Q2 over what? R. Therefore, the formula for work will be equal minus K Q1 Q2 over what? R square. This is the formula for what? E. You must put this. Why I like this minus? As we can prove this formula for work in two ways by using differential calculus method or integral calculus method. You will end up with minus. This minus tells us that what is bring the charge from what? From infinity. That's the meaning of the what? Of the sign of work what? Of work done. Take this question. Example. Example 1. Tell you what? 2 charge plus 2 microcoulomb and plus 5 microcoulomb are 10 centimeter apart. Then determine the work done required to set up the system. Look at this question. We are given this. The first thing is solution. What is charge Q1? Q1 is 2 microcoulomb. Then what? Q2 is what? 5 microcoulomb. Distance apart is R, which is 10 centimeter or 0.1 meter. Determine the work done. What is the work done? Using work equal to the what? K Q1 Q2 over R. Apply the work done. We have 9 multiplied by 10 raised to the power 9 into the what is Q1? 2 times 10 raised to the power minus 6 multiplied by what? 5 times 10 raised to the power minus 6. Everything into the what? Distance apart is 0.1. So by pressing your calculator, press it and tell me the what? The final answer for work. If you press it, this is 10. Rather than this, we have 0.9 joule. You know that what? Work is measured in what? In joule. So the final answer here for work, the work done that is required to study was 0.19 joule. Okay. Now, so if you ask to find the work that's required to bring two charge near each other when they attract or move away from each other when they repel, here is the formula for what? For work. And the next thing we are going to treat now is electric potential. Electric what? Electric potential. So the electric potential is denoted by what? Capital letter what? V. And what is the electric potential? Electric potential can be defined as the work done due to or can be defined as the what? As the work done to bring a test positive charge from infinity to the reference point. Yes, electric potential. This can be defined as the work done to what? To bring a test positive charge. Test positive what? Charge. Q from infinity to the reference point. To the reference what? Reference point. For mathematically, math what? Mathematically, electric field potential is the force per unit area. Electric field what? Electric potential V can be defined is the force F per unit charge, not area, sorry, per unit what? Charge. It is measured in sorry, is the force, is the work done. Sorry, is the what? Is the work done, is not the force. Is the work done per unit what? Charge. So it is measured in volts or joule per coulomb. Or volt per meter. So it's also a vector quantity. Also a scalar. What happened to me this afternoon? A scalar what? Quantity. So mathematically, the electric field potential, what? Electric potential V is what? Work over what? Over charge. So if it shows further, V is what? Work over what? Over Q. So we can call this one what? Equation what? Equation 1. You can call it what? Equation what? Equation 1. Recall that, no, call this equation what? Equation 2. This is equation what? Equation 1. Now say what? From equation what? Equation 1. Work is KQ1 Q2 over what? Over half. Let's substitute for work here to look at what? What will happen? So by substituting for what? For work. Yeah. We will have what? Electric field potential V. What is the work? Is Q1 Q2 over what? Half. Oh, over half. Everything divided. This divide, let's put it here. Divide by what? Q. I change this divide to what? To this Q. And this, by doing that, this expression is the same thing as what? KQ1 Q2 half to what? 1 over what? Q. So if you cancel one Q here, you now have left what? Potential will be KQ over what? Over half. So this is the formula for electric potential. You can have it in this form, equation 2, or in equation what? 3. Depend on parameters what? Given. We are given work over charge. We apply this. We are given charge over distance apart. So we apply what? This. Let's solve to one question on what's on it. Yes. Take this question. Calculate. Let me call it what? Example 2. Calculate. Calculate the electric potential V at point 2 centimeter, point 2 what? Let's call it 2 what? Centimeter due to charge plus 3 microcoulomb. So we have to calculate the what? Electric potential at point 2 centimeter due to the what? Charge plus 3 what? Microcoulomb. So here it's also simple. The next thing that we can do here is what? You will write solution. Parameter given. We are given R to be what? 2 centimeter. In meter is 0.12. Good. And then we are given charge. Q should be what? Plus 3 microcoulomb. Good. Find potential. In this question now, we are given what? Charge and distance. So we apply this to question 3. So using what? V, go to what? KQ over what? R. What does K stand for? You know K is constant, which is what? 9 times 10 raised to the power what? 9 multiplied by what? 3 into 10 raised to the power minus 6. What is R? Is 0.2. So if you press the calculator, 0.2 divided by what? 3 times 9, 27, 0.2, 27, that will be 1.35 times 10 raised to the power 4. Abi? Please press the calculator. What is 1.35 times 10 raised to the power 4 volts, if I'm correct. So this is the what? Electric field potential. So let us look at what? The system of charge or electric field potential. Electric potential for system of what? Of charge. So the next one is electric potential for system of charge. Yeah. That's what the in system of charge. In system of charge, the electric potential V, electric potential what? V at a point due to this charge, due to this what? Charge is the sum of individual potential. Individual what? Potential and individual potential, no, to individual charge. To individual what? Individual charge. See, for example now, if you have a system of charge in this form, let me call this place what? Q1, and I assume that what this is Q2, and this side is what? Q what? 3. Let me call this place what? Q or point of what? Yes, a test charge. Distance here, from here to here, let's call it what? R1. So from here to here, let's call it what? R2. From here to here, let's call it what? R3. If you are now asked, what is the electric potential for this charge here? Let me put this, let me call it P. This is what? Test charge. It will now be what? By using superposition theorem, the total charge will be equal to the what? V1 plus V2 plus V3. And we all know that what? The total charge T, V1 will be what? K, Q1 over R1 plus what? K Q2 over what? R2 plus K Q3 over what? R3. So what is the common factor? Take it out. The common factor here is K. You will now have T total should be what? K into what are you going to have now? Q1, Q1, R1 plus Q2, R2 plus Q3, R3. So this is what? How we calculate the what? The effective electric potential. That's the what? Equation what? Equation 4. Let me solve one question on this. So let's solve this question on electric potential. Calculate the electric potential at point P due to the charge in the system below. Solution. Let us name this Q1, Q2, Q3. If you could still remember, the total potential in a system of charge is K into what? Q1, R1 plus what? Q2, R2 plus Q3, R3. This is a formula that we can use to determine the electric potential in a system of charge like this. So the E total, this K is 9 times 10 raised to power 9. This Q1 is 2. Is 2 times 10 raised to the power minus 6 over what is the distance between this Q1 and P? Is 20 divided by 100, 0.2 plus Q2. Q2 is minus 3 times 10 raised to the power minus 6. This minus there, you will not neglect it. You put it there. Over distance between the Q2 and P is 10 divided by 100. We have 0.1 plus the third one, which is 4 times 10 raised to the power minus 6. Distance between this and this is 0 point what? Is 0.1. By doing that, E total will be 9 times 10 raised to the power 9. Everything here will be, if we divide this by this, we have 1 times 10 raised to the power minus 5 plus divide this by this, you have minus 3 times 10 raised to the power minus 5 plus 4 times 10 raised to the power minus 5. So the E total will be what? 9 times 10 raised to the power 9. Add this together or take this out. We have 1 minus 3 plus 4 into bracket 10 raised to the power what? Or times 10 raised to the power what? Minus 5. I took it out. So the E total will later end up to 9 times 10 raised to the power what? 9. Add this together. We have 5. And this we have 2. Give us 2. Take this back. 9 times 10 raised to the power minus 5. 2 times this, we have E total should be 18. Then times 10 raised to the power 4 volts. That's what? Volt. Or we can also call it what? E total should be 180 kilovolts. So that's the answer for that. The next aspect that we are going to treat now is potential difference. Potential what? Difference. So let us look at potential difference. Potential difference. We can call it what? V. Is what? Electric what? Potential. So potential difference is defined as a difference in electric potential between 2 points. This is what defined as the difference in electric potential between 2 points. So mathematically, potential difference is given a change in what of V, where this change in what V, it may be what? VA minus VB. Yes, it will be VA minus what? VB. Where and VA is given as what? KQA over no Q over RA, and VB is what? Q over what? RB. So if we have it in that form, substitute for this now. The potential difference will be what? KQ RA minus KQ RB. The change in potential will be KQ into the what? RA minus RB. So this is a formula to calculate potential difference, which is what? The difference in electric what? Electric difference in electric what? Potential. So if that be the case, let's solve one question on it. Yes. Let me call it example 5. Determine the electric potential at points X and Y, which are 12 to 18 centimeters respectively from 3 charge. This, the charge is plus 3 from. So if I assume that what? This place is my point X, and this side is my point Y. 12 and 80 centimeters respectively simply means what? Distance between 3 and X is 12 centimeters. 18. So distance between what? Y and this, its own distance is 18 centimeter. You are now asked what is the potential difference between the 2 points? So we can now say what? At point X, the potential difference at point X, V of X is equal to the what? KQ over what? R of X. By doing this, V distance of X, it will be 9 times 10 raised to the power what? 9 into bracket what? 3 times 10 raised to the power minus 6, 27. Subtract this. What is the distance will give us? 12. 12 is what? 0.120. That will be distance into meter. By doing that, Vx will give us what? 225 kilometer. A kilovolt. So the next one is at point Y. For point Y, what are we going to have here? We have X, we have potential difference for y equal to the KQ RY. So which is later equal to the what? V of y is 9 times 10 raised to the power 9 will be equal to the what? Charge this minus 9 over what? Distance 0.218 everyone 0. What? 18 into meter. What are we going to have? By 3 times this 27 divided by this we have 150 kilovolts. If it's 150 kilovolts, the potential what difference change in this will be what? Vx minus Vy, which is 225 volts minus 150 everything volts. So what will be the final answer? The change in Vxy will be 150. It will remain because 100, 125, 125 kilovolts. So that what the 75 will be 75 kilovolts. 75 what? Kilovolts. So that is for that. The next aspect now is let us look at what? The work done in moving charge between two potential difference. The work what? Work done in moving charge between two potential difference. Between two potential or between 2 points of different potential. Between what? Between 2 points of different potential. Yes. So the work done in a moving charge between 2 points of different potential, yes, can be determined by the what? The magnitude of work done in a charge. In a what? Charge Q is the product of charge and electric potential. Product of charge Q and electric potential E. That is, we cannot say what? The work done E is the product of what? Of charge Q and what? And V. So this is the what? How we can express work done. the work done in a moving charge between different potential. The work done we done before is in a moving charge between 2 points with distance apart. But here is work done in a moving charge between different potential. So this is the work done here. And let's solve this question on it. Call it example what 6. Calculate the work done in moving charge plus 4 colon from point X. Where potential is 60 volts. Yes. Where potential is 60 volts to point Y. Where potential is 40 volts. Look at this question. Yeah? We are given solution. We have to find the work done. We are given what? Charge. What is the charge? Is plus 4 colon. We have two potential difference. What is it? You can say what? V1 is 60 volts and V2 is what volts. What is the work done? So the work done is what? Our work done is unknown. And I say using the work done will be equal to what? Q change in V. The change in work done equal change in what? V. And now have what? The work done should be what? What is the charge? Charge is 4. What is change in V? 60 minus 40. So the work done will be what? 4 times what? 20. The work done will be what? 80 joule. So if you are asked what? There are two formula for work done in this topic. Know that work done, you can have it in terms of what? Of charge. It will be K1 2 over half. If work done of moving to charge, so near each other by distance. But work done in a moving charge between two different potential, that will be what? Work is what? Charge change in V. Please, they are not the same. They are not. Don't be confused. So, yes. Let us look at what? Relationship. Let me use blue marker. Relationship between electric field intensity, which is E, and electric potential, which is what? V. So, the relationship between what? E and V. You can say that from work equal to the what? Force times what? Distance R. So if force equal to what? Distance what? Distance R, you can agree that force times R. And again, where force is equal to what? EQ. From, you know that what? Electric field intensity is force over what? This. So from there we have this. You can put it to the force here. The work will be what? EQR. Let's call it what? Equation what? Equation 1. If this is equation 1, you can also say that what? From work done in moving charge from different potential, you can have work should be QV. For this what? Equation what? Equation 2. Work from force and distance, we have this. Work from moving charge from different potential, we have this. By equating what? Equate 1 and 2 together. By equating equation 1 and 2 together, we are going to have what? What is 1? EQR is equal to what? QV. You cancel Q. At the end of the day, you can have what? Electric field intensity is equal to the what? Electric field potential times what? R over R. This is the formula. Equation what? Equation 3. Some textbook can write it in this form. E equal to what? V over what? Over D. Is still what? The same thing. Which is distance, potential, this. Please note this formula what? Formula A, B. Let me solve one question on this formula what? On this formula. Let's solve this question. Solution. Two plates of capacitors are 2.50 apart. Simply means what? The distance is 2.5 apart. The potential difference of V is 72 volts. What is electric field intensity? Our field intensity is unknown. So apply this what? Formula. Which field intensity is V over what? D. Field intensity is 72 over 2.5. 35 divide it, we have 288.8 volts per meter. That is the electric field watts.